All right, now here, I think, not mistaken, Chang Wai didn't do, is it? Okay, so I think it's quite easy. Try out on your own, and answer is given here. Or is it doing? I'm not very sure, but I remember, okay, I checked and I couldn't find. Okay, so try on your own. This is the answer. All right, then later on, of course, draw the circuit. So if really cannot do, then only we come back to this. Okay, that is the question number 2. All right, then third question here. Figure question 3 here shows a state diagram for a synchronous sequence detector. So they are going to detect a sequence. Okay, they are going to detect a sequence. So it's a sequence detector. So the example that I shown you all, okay, how to build a state diagram also can be, okay, named as a sequence detector. They detect certain sequence, then only, okay, they output you a 1. All right, so this detector here has 2 inputs, X and Y, and a single output Z. The transition paths are labeled with the input values causing the transitions and the resulting output value. For example, okay, if you see the questions are this one here is the X, this is the Y, and this is the output Z. Okay, ask you to determine the sequence. So when am I going to get Z equals to 1 from any initial state? I never tell you which one is the initial state. All right, but looking at these simple flow charts here, you see, okay, when sequence not correct, you see so many of these sequence which is not correct here, they will remain in this initial state. So this will be our initial state. Okay, correct sequence, I move on. Correct sequence, I move on. Then correct sequence, I move on. Third, correct sequence, I move on, and I output you a 1. In this whole, okay, state diagrams here, I only saw this output here is a 1. So that indicates to me that, okay, the sequence has been detected. All right, and look at here, it's a 0, 1. All right, input, then 1, 1, second one, and this one here, 0, 1, and lastly, okay, the 1, 0. So what is being shown here is correct. All right, and Chang Wai also, okay, put it at the side there. Okay, correct. Okay, then subsequently, okay, question say ask to design, okay, this circuits here, or okay, based on D flip-flop. Look at the question first. Draw the state transition table, which for every initial state shows the next state and resulting output for all the possible inputs X and Y. Then after that, okay, use a D flip-flop, and they specify using only NAND gate. Design this circuit to implement the detector. All right, so your flip-flops here, you are going to label them as A and B, as what is being mentioned in this so-called state assignment. And this is the answer that you are going to achieve, okay? So, someone have done everything, and I double check. Okay, for this is the next state. This is the output. I got only one output here. All right, and I filled up. Since this is a D flip-flop, it's the easiest one, okay? Basically, you copy down this. Of course, when you copy that time, be very careful, provided, okay, you arrange your, this present state, okay, similar to your Kano map, okay? The next state, okay, for the conditions of your X and Y, also similar to the Kano map, okay? 1, 1, then only 1, 0. Here, 1, 1, then 1, 0. So you fill in here and do the looping. There is no such thing as don't care in this case here, because I use up all the possible combinations, okay, 4 states. And at the same time here, okay, this is a D flip-flop, so there's no such thing as a don't care condition. So we do looping, okay? This is the result. So whether you show me this one or not really important. But then when you draw the circuit at time, you must know that every time 2 level, okay? 2 level, okay? Same thing for this one. You don't show this, it's okay. You get this one here, then 2 level. Z only one, so no need to prepare Kano map. Can straight away get from the state transition table. So this is what I meant by 2 level. Okay, so you cannot have just one and then a masuk for your D. Sure wrong. Okay, will be 2 level. All right, so use only NAND gate. All right, and also be very careful. Here is A bar. Don't give me don't do it this way. Don't give me this one. Okay, because my A bar come from the Q bar. So this is wrong. Okay, so just label accordingly and take, okay, the output of the flip-flops. Okay, make it connect to here. Then this one here actually is the Q output, okay, from this flip-flop, okay, which I label it as a flip-flop A here. Okay, this is a flip-flop B here, and so on. Okay, so mustn't forget about your clock. Okay, clock and this output usually okay, students will forget about it. Okay, then your 2 marks gone your design this circuit here tak boleh pakai one because it will never work and it will never give you an output because there's no output at all. Okay, so no 1 mark just like that Okay, any questions for this one here? Question number 3. Question number 4, I also I didn't do, okay, I didn't look at it at all. So we'll do it together. And if you think, okay, that you can fill up, okay, go ahead. Anyone want to try this from what I explained just now? Okay, so of course, first thing I do here is read the question, then I understand this circuit. Now they say that sketch the Q output waveform relative to the clock for the H trigger JK flip-flop. Be input as shown. Okay, now my JK no longer connected to 1, so I have a pattern of my JK. All right, which is given by this one. Now, also they say that assume that Q is initially low. Okay, so then next, okay, I analyze these circuits here. This one here working, preset working when it is logic 0, clear working also when it is logic 0. Okay, so let's see, okay, whether this waveform here is it correct. Okay, and of course, okay, I must know my JK very well. Okay, so first thing is, okay, this one here, falling edge, and a question already, okay, help you a little bit, okay, by drawing all the falling edge for you already. So something might happen, okay, at this instance. Might only, okay. Then I also need to add in on my own, okay, some projection line, for example, the preset. Okay, preset add up in, okay, and also my clear we add in. And on top of this, okay, of course, okay, be very careful of the conditions of the JK. Okay, first one question says start from 0. So initially, actually, if question never say that, okay, it's initially low, you'll find that because of this clear, also it is going to be low. Because of this clear, clear is active, right? So it is also going to be low. Once it changes to 1, nothing happens. Okay, so I wait for the, okay, change to 1, okay, nothing happens at this instant until the next clock pulse comes in, and you find that, so when you are checking, you always check what is in front. K is a 1. So K is the 1, make it reset. Okay, because of this, it reset. Next, this is 1, this is 1. So I toggle here. Now this is 1, this is 0. Check what is in front. Okay, what is in front? So this is again is a set. So continue. Okay, continue. Then this one set again because J is a 1. So I continue until here and suddenly, okay, a clear comes in. Yep, for here I now change to 0 until the next clock pulse. Okay, then I check again. Wow, set again. Okay, then now here 1 1. So this K, okay, happens at this instance, okay, you no need to bother because your JK will only work at this falling edge here. So 1 1, I am going to toggle. Okay, 0 1, reset. 0 1, reset. Okay, suddenly, okay, something happens here. That is a preset now become 0. So preset is working. So immediately preset becomes 0. Yeah. Okay, I set the output to become a 1 until, okay, the next falling edge. Okay, until the next falling edge. Then in this case here, well, this will no continue until the next falling edge. Okay, until the next falling edge. That time you see that, okay, checking here, J now is a 0, K is a 1. So this is a reset condition. So because of this condition, now my system, my output, okay, go back to 0. Then both are 0. So continue. Okay, check here, still both are 0. So I still continue. This is 1 0. So set. Okay, correct now. So you must know your truth table very well. Okay to all? Anyone got anything to ask? Okay, if not, okay, then you are given this state diagram. Okay, you are given these state diagrams here. Slightly different from previous one. Now, okay, my state here cover, okay, 3 flip-flops. And I have only a single input. Okay, this state diagram here is for sequential circuit. Now, the circuit uses 3 JK flip-flops ABC, single input X and single output Y. Draw the state transition table showing the excitation required by the flip-flop A, B, and C. Okay, they actually mention about the excitation required. So that is to say that in the state transition table, I must include, okay, input to the JK flip-flops. Because of this word, excitation required. Okay, not just the transitions table alone, but also what should be the conditions of the JK. Okay, so Chang Wai got this part done. Okay, so this is maybe put down here, this is wrong. Okay, so in this case here, I enlarge it, okay? Otherwise, okay, I actually really cannot see all this. Okay, so this is the state transition table. Okay, so maybe I just put down here. Need to include input to all JKs. Okay, that means that, okay, extra columns. to indicate, okay, the JA, KA, JB, KB when x equals to 1. When x equals to 0, then when x equals to 1, also include. Now, Tanwa is good already, so he exclude this part and straight away fill in into the Kano map. So, based on, okay, what you filled up, okay, for this input to this JK here, we fill in into the Kano map. So, there's no space here, and I don't want to mix it very messy. All right. So, from what you obtain here, you fill in into the Kano map. And this is the expressions that you are going to obtain. And in this question here, they never mention using, okay, what type of logic gate? Those suka hati. Okay, so I check a few. All right, so here I use N. So this part here, use XOR, more easy. All right, rather than, okay, using 2 N gate plus 1 OR gate. Okay, and for the case of connected logic 1, you can just draw it as in this form. All right, so only input you require a NOT gate. For the case of the state, no need. Okay, so very neat diagram, except that, okay, maybe next time, okay, you put K first, then only put J, so you don't have an overlapping over here. All right, so this one draw on this side, this one draw inner a bit. Okay, that is this question 4 here. Okay, next look at question 5. Still got waveform, and this waveform here is quite easy. Because last time they have a receipt paper only for receipt students. So sometimes receipt paper come out is slightly earlier, okay, because the result is kept as C. All right, so in this case here, we look at this one. Now, maybe we should talk about it, okay? If exam come out, these are waveform and it sure will come out. So give you a patterns of waveform. So please, okay, trace. If it's a hard, a face-to-face physical exam, you use the answer booklet provided, quite thin, okay, you can trace the waveform and then draw your output. Because if you don't trace, you just give me the output like that, okay, I'm going to give you, okay, 0 mark. When this thing happens, macam mana saya boleh tahu? Understand or not? So in this case here, please trace the input waveform, then draw the output waveform. Clear to all? No input waveform, no marks. Okay, for this one here, now circuit is here. So you find that this one here will work when it is 1. This one here, although I don't draw a bubble, but I tell you that this clear here is 0. Some, okay, data sheet, okay, they put it this way. So this one here responds to 0. So therefore, in this case here, 0. Other than this, okay, no more. This one responds to 1. Okay. And maybe I draw this one as well. This one also. And this circuit here responds to leading edge. All right. Initially low. And my JK actually keep on toggle. JK keep on toggle. So anyone want to amend on these parts here? Okay, try, okay, draw the waveforms over here, which you think is correct. Anyone? The one Chanwai, Chanwai should be no problem to pass and score, I think. Others, okay, a little bit worried. Is Yinshan here? Is Yinshan here? Or Lenjian here? Lenjian, are you here? Okay, Lenjian, can you help to draw this? This is considered okay easy waveform. Wenjian, okay? Straight line below, apa ini straight line below? Of course, it's a straight line. Okay, they start from logic 0. Okay, forgot the name. Okay, they start from logic 0. Okay, low. So straight line below. Okay, follow your instruction, straight line below. Okay, start from logic low until I draw. Okay, if you ask me to stop, I stop. You don't ask me to stop, I continue to draw. Okay. That's one too slow. Okay, I redraw. Now you are going to find that okay, I may need to draw something. Okay, something may happen at the clock input. Okay, here. So prolong this projection line. Okay, so take it as all these are straight line. Okay, I am going to draw until okay the first rising edge. Okay, I stop here. So next instruction, what should I do? Rising edge. Don't use this word. Use proper word. So at the rising edge, already, okay? At the rising edge here, I check both my preset and clear actually not working because okay, preset working when it is 1, clear working when it is 0. Now it's the balik. So preset and clear both are not working. Therefore, J and K toggle, okay, toggle until every time when there's a rising edge, I stop to check what is going to happen. Okay, therefore, no, rising edge, okay, add in on your own. And I found out now clear is a 0. With this clear equals to 0 and also rising edge happens, okay, in the middle of this clear here equals to 0, then you're going to find that my output will go through until, okay, even though they stop already, but the flip-flop will only work at next rising edge. So this is the one. And now both not working again. I toggle happily. I toggle not working. So black color one is from the clock. Nothing happened. Now until here, okay, continue to toggle and for the A, my preset working. Preset working means that now I'm actually at logic 1. I continue to set until here. Preset now. Okay, go to low already, but I will continue until the next rising edge. Then only I continue to toggle. Okay. So this is a waveform that I am going to see. Okay, this is the part that is not correct. Asynchronous. Always remember that your preset and clear here, unless question says synchronous lah. Otherwise, okay, it is asynchronous. Okay, there are a lot more waveform. I am not going to discuss everyone for you all. I want you all to try. All right. Otherwise, okay, I will do everything already. Okay, so now this is question 5. This parts here. So why do you do this part? This part? Okay, so is don't know how to do or need my discussion or what? Find too boring already, do too many questions. Whole class so lazy, only you so hardworking, oh. No idea how to start. Okay, anyone have tried these questions here? Okay, anyone try this question? Can share with us. Mistake, okay, wrong doesn't matter. Okay. Now, this question here actually terbalik, okay? They give me the equation that they found out from the Kanu map already. Then they ask me, okay, how is the state diagram looks like? Okay, and also, okay, the waveform looks like for this one here. So I will do it sort of based on, okay, this equation given. Okay, so this equation given. So where should I do it? Okay, maybe we do it here. Okay, let me just copy down the question here first. I have for my JA, KA given. This is given. Oh. Given JA same as KA, same as 1. JB equals to A. KB equals to AD. Okay, next I have my JC equals to ABD. KC equals to AB. Next, JD equals to AB. KD equals to ABC. Okay, and maybe need to go through the question a little bit. Otherwise, okay, you all may not know what am I talking about. Okay, a synchronous counter is composed of 4 JK, ABCD, respectively. The J and K input to every flip-flops here are as follows. This is the expressions. They ask me to draw the circuit diagram. Okay, and analyze the circuit to produce a waveform timing diagram. Now, draw the waveform diagram, draw the circuit diagram here. I leave it on your own. So you base on this one, okay, draw something very similar to what Chamwari has done, okay, earlier, something like this. Okay, so I leave it to you to draw on your own. Unless Lily cannot, then only ask me again. Draw on your own. Okay, this one. What I want to do here is analyze the circuit to produce a waveform timing diagram. I need to analyze the circuit first. Okay, and then only I can come up with a waveform diagram. Okay, we show the output state of each flip-flop with respect to the clock and as it goes through the full counter sequence. Then they ask this one here. From the table that I produce, okay, I will be able to answer what is modulo of this counter. Anyone, okay, still remember what does it mean by modulo? Okay, number of states. There are how many states, okay, in this circuit here? Asking you, okay, my answer is 10. Okay, assume that initial state we all flip-flops here in the reset mode, because in this case here, I will know where to start. We start with all the outputs here, A, B, C, D, all are 0. Okay, so this is what we are going to do. So we prepare the analysis. So in my analysis here, I have a present state. So I already know that, okay, this present state here, I'm going to label then as A, B, C, D as stated in the question. All right, so there's no external input in this circuits here. So your next state is quite straightforward. Okay, it's given as the A plus, B plus, C plus, D plus. Next state. And what is the next state that I'm going to go? It depends on my input to J and my K. Okay, so I have 4 flip-flops here. Okay, then JD, KD. Okay, this is the input to this flip-flop, so I can draw it now. Okay, question says start from 0. Okay, start from 0. Okay, what is the next state that they are going to go? Actually, I don't know yet, but based on this equation given to me, I know that, okay, my J and K always 1. Okay, so no need to worry about this, it's always 1. But my JB, okay, is depending on A. So in this case here, now my A is a 0. My KB, okay, depends on AD. A is a 0, so AD definitely is a 0. I got A here, so do it fast. A here, all 0. Then with this, okay, you know that your A is going to toggle. Because this is all 0, so they are going to remain. So this will be my next state. Now, this A is a 1. This is always toggle. A is a 1. But D is a 0. Okay? B and D, 0. B is a 0. B is a 0. B, C are 0. Toggle. Okay? This condition is a set. These two follow. Okay? Then I copy this one to here. And input is 1, 1. Now A is a 0. Anything with A equals A, you are going to have, because every, okay, of these expressions here contain A. So no, all 0. Toggle. Remain. Okay. Okay, so take this one into here. Then you find that, okay, this is 1, 1. A now is a 1. A is a 1. Okay, A is a 1. This is a D. D is a 0. D is a 0. B, AB, 1. So C correct. AB is a 1. Okay. C is a 0. So with this, okay, I'm going to, this one here, you're going to find always toggle. A always toggle because this is connected to 1, 1. So this one, set. This one here, reset. This one here, set again. Okay. So with this, okay, I am going to have my 0, 1, 0, 1. So after every 4, maybe I draw a line so that easy for me to see. So this one, now move on to here. So I'm going to toggle. A is a 0. Okay, A is a 0. So A is 0 very fast. You can draw. You can draw the conclusions for all other input. So toggle, then the rest remain. So becomes 1, 1, 0, 1. Yep, correct. So this 1, 1, 0, 1 come to here. I toggle right first. A, B are 1. A is a 1. D also 1. D is a 1. AB is a 1. 1. ABC. C is a 0. So toggle. Yeah, toggle. This one, toggle. This one, set. So 1, 1, 0, 1. I get 0, 0, 1, 0. Yes, correct. After that, I shift this one to here. Okay. So I'm going to get this one again is a 1, 1. Now A is a 0. When A is a 0, very easy. You fill in everything with 0. So you toggle remain. Okay, so I cannot see the equation already. All right, so you find that next, this will be the 1. So I leave it for you to fill in this part. I give out the answer for this one. So this is 0, 0, 1, 1. You get 1, 0, 1, 1. You find that you are going to have 0, 1. So yes. So I'm going to have a 0, 1, 1, 1. Then next, okay, with this a 0, 1, 1, 1. I'm going to have a 1, 2, 3, 4. After this 1, 2, 3, 4, I'm going to go back to 0, 0. So this part you'll fill it in on your own. Okay. Okay, then okay, now double check. This is my initial starting state. When come to here, okay, it go back to the initial starting states already. Therefore, you find that, okay, I calculate the number of state that I'm having here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, the modular is 10. Okay. Now, this is I'm doing the analysis. Then after this analysis here, question asks you to produce a waveform timing diagram. Okay. In the waveform timing diagram, waveform timing diagram, you draw on your own first clock. Okay, your clock here contains at least minimum, okay, 10, but not enough to show, okay, that it repeat. Then 11 clock pulse. Prepare 11 clock pulse of this. So I will draw only a few. Okay, question never talk about preset, never talk about clear, so don't make your life miserable by adding unnecessary thing. I suka hati, just a label, easy for me to know which crowd am I in now. 4, 5, 6, 7. Continue. Wow. 8 and so on. Get 11. And next, I need the A output, I need the B output, C output, and the D output. Of course, all these, start from, will happen, or will change, according to the clock pulses. Question say, all of them start from 0 as what I have, from my table earlier. This is the 0. Then first one, if you still remember, I toggle. B remain. I draw this one is because of this. 1, 0, 0, 0. After this 1, 0, 0, you are going to get 0, 1, 0, 0. So 0, 1, 0, 0. Third one is 1, 1, 0. This one keep on toggle lah. All right, always toggle. 1, 1, 0, 0. Can I stop here and you all continue? Can I stop here? You all continue? Or anyone have question you think you cannot do? So this is what we call it as a timing diagram. Based on the clock. So produce 11 clock pulse. Maybe I just complete this one. Then you all go and draw out the waveform pattern here. Now you draw until the waveform repeat. Then you can stop already. Just put down one word, repeat. Class, all right to all? Continue this waveform here. So this is on this question. So I consider I have done. So this part not yet. So we will do it. So I will continue from question 6. And question 6, actually I checked already. It's correct. Right. But there are still a little bit of parts, we need to go for discussions. Then a lot more waveforms here. Those, today attended the class but never do anything, please complete this waveform. All right. These are from my past year paper. All right, so try out all the waveforms. I didn't check, so not sure whether right or wrong. So if you think it's wrong, amend it. Then Monday, we will look at this way. Now we add in a multiplexer, to replace those logic gates. So that we can get an output. And Monday also, I will return your this assignment. So any question before we end for today's class? So Monday we will start from here. Others, I stop halfway one. Please continue and get it done. Then we still have one more topics to go. That is ASM. If no question, thank you for paying attention. So today, Yinshen absent, so I mark him absent. Thank you. And I'll see you all again on Monday.